On with Unit 8. This is Learning Target 8C, which is going to be all about factoring polynomials. And in this first video, we're going to learn how to factor a polynomial of the form x squared plus bx plus c. So here, our x squared term, notice, has no number in front of it. In a later video, we'll talk about what happens if I have a number in front of my x squared. We're also going to learn how to factor perfect square trinomials and how to factor the difference of two squares. So I want to kind of recap what we did in our last video. So our last video, we learned about the FOIL method. So we learned about what happens if I have a binomial, let's say like x plus 1 times x minus 3. We learned how to multiply these out. So we learned that using our FOIL method, let me have enough space here, I can go x times x, which will give me an x squared, x times negative 3 by multiplying my outer terms to get a negative 3x. If I multiply my inner terms, we get plus x, and if I multiply my last terms, I get negative 3. So this was our foiling method. We then learned that, we need to combine some like terms, so I end up with x squared minus 2x minus 3. So starting from our two binomials multiplied down to what we call standard form, this is what we call foiling. And we talked about that in our last video at the end of Learning Target 8B. What this video is going to focus in on is how to factor these. So factoring these undoes the process that we learned with foiling. So foiling multiplies everything out to standard form. Factoring takes a polynomial in standard form and rewrites it as a product of two factors. So I want to make sure that we understand what each one of these pieces is because they are very linked together, and we can actually always check our work for one of them by doing the opposite. So foiling is when we multiply them all out to get down to standard form. And then factoring is when we take a polynomial that is in standard form and we rewrite it as a product of factors. So as the last piece of vocab down here, this is what we would call standard form. Remember, standard form is where I have the highest exponent down to the lowest exponent term. And then our form up here is what we would actually call factored form. So in our last video, all of our problems actually started in factored form, and we practiced how can I multiply those or FOIL those two binomials out to get it back down to standard form. In this video, we're going to do the opposite. We're going to start with a polynomial in standard form and learn how to factor it. So let's look at what the definition of factoring is when I have a leading coefficient of a 1. So I have a 1 technically in front of my x squared. Our goal here will be to find two numbers that multiply to be c. So they multiply to be the constant term, so c is for the constant, and they add to be our b term, which is the coefficient on the x there. Again, we can always check our answer by foiling this back out. Well, I want to use this example over here since we already know what the factored form should be. Let's look at this polynomial here. So we have x squared minus 2x minus 3. So in this, our b value is going to be negative 2. Since that's the number in front of the x squared, you always want to make sure you take the sign with it. And our c value is going to be negative 3 since that's our constant term. Again, make sure you take the sign that's in front of that number as well, so both of these will be negative. Our goal was to find two numbers that multiply to be c, so multiply to be negative 3, and add to be negative 2. The method that I'm going to teach in this video is what we call the X Games method, and this is just a way to organize your work. Now there's actually lots of ways to factor and different kind of arrangements and methods per se to organize your work, but in this video I'm going to focus in just on the X Games method. And the way we organize our work here is we put the number on top that we want to multiply to be. So I'm going to put negative 3 on top. Then we put the number on the bottom of the x that we want to add to be. So I would put the negative 2. Now in these two opposite sides, we want to come up with what those two numbers are. So we have to think about what two numbers multiply to be 3 and add to be negative 2. Well, I want to think about factors of 3 then. So factors of 3 will help me come up with some options. So the only two factors of 3 happen to be 1 and 3 though, since 3 is a prime number. So I know that one of these has to be a 1 and one of these has to be a 3. Now I have to figure out the signs. So because I need to multiply to be a negative number, it means one of these two numbers needs to be negative then. But I can't just put it on either of the two, I have to be specific because it also needs to add to be a negative number, which means the negative sign needs to go on the bigger number. And the reason this works is because 1 times negative 3 does equal negative 3. So 1 and negative 3 multiply to be negative 3, and they also add to be negative 2, which is what we were after. So 1 plus negative 3 equals negative 2 then. How I use this then is if I go look up here in my factored form, 1 is represented with the x plus 1, and the negative 3 is represented with the x minus 3. So once I come up with those two numbers, I can write that in factored form by saying x plus one of the numbers in parentheses times x plus the other number in parentheses, and that will be our factored form for these guys. Let's look at some other examples in here. So our first example actually says x squared plus 8x plus 15. So when I'm organizing my x games method over here, I need to figure out what two numbers multiply to be 15, because 15 is our C value, and add to be 8, since 8 is our B value. To help me think about this, I'm going to come up with factors of 15 on the side over here. So one factor that I always have for every number is 1 and that number. So I have 1 and 15. The next set of factors I would have would be 3 and 5. And then those actually happen to be the only two sets of factors for 15. So it has to be one of those two. So if I start looking at this, I need to multiply to be a positive number and add to be a positive number as well, which means I shouldn't have any negative signs then. So 1 times 15 will be 15, but 1 plus 15 will not give me 8. So 1 and 15 won't work. So let's see if 3 and 5 work. So 3 times 5 is 15. So the multiplication works, and 3 plus 5 does equal 8, so the addition also works. To write this in factored form then, what I'm going to have is my two linear factors. Well, I'll have x plus our first number, so x plus 3, times x plus our second number, which will be x plus 5. That there then is our factored form of the polynomial that we were given. Let's look at example 2. So example 2 says x squared minus 11x plus 24. I want you guys to pause the video and decide what is your b value and what is your c value. So here our b value is going to be negative 11 and our c value is going to be positive 24, which means in my x game setup or organization over here, I'm looking for two numbers that multiply to be positive 24 and add to be negative 11. Now you might have already thought of those numbers off the top of your head, which is great. If you haven't, that's okay too. Let's go ahead and list a couple factors of 24 to get some possibilities here. So the first set of factors I always have is 1 in the number itself, so 1 and 24. I also have 2 and 12. So remember, I'm looking to add up to be negative 11. What I'm noticing is because I have to multiply to be a positive number, that means these need to have the same sign. So they're either both positive or they're both negative. Because I need to add up to be negative numbers, they're going to both need to be negative. So negative 1 and a negative 24 is not going to give me a negative 11. Negative 2 plus a negative 12 will also not give me negative 11, so those two won't work. 3 and 8 would also be factors of 24, and if I make both of those negative, I'd have negative 3 and a negative 8, which actually does add up to be negative 11 then. So our two numbers that multiply to be 24 is going to be negative 3 times negative 8, and negative 3 plus negative 8 adds to be negative 11. Now, if this one didn't work, I could go down and try the next set of factors. So 4 and 6 is also a set of factors of 24, but once I get a set that works, there's no need to keep writing them. The last thing I need to do is write my final answer, which is factored form. So in this case, because I have a -3, I'll have x minus 3 as one of those factors. And for my second factor, we'll have x minus 8. Do notice that whatever the sign is that I'm finding in our X Games chart over here is the sign that I'm writing with it. So because I have a -3, I'm writing x minus 3. And because up here I had a +3, that's why I wrote x plus 3. So those signs do matter, and it's going to make, although it's a subtle kind of change, it actually makes a big difference in the problem. Okay, let's look at example 3. We have x squared plus 2x minus 15. Why don't you guys pause the video and come up with our two factors on your own first, and then we'll check it together. So using our X Games, I'm looking for two numbers that multiply to be -15 and add to be +2. So if I start thinking of factors of 15, 1 and 15 would work. I would also have 3 and 5, and as we saw in example 1, those are our only two factors of 15 then. Well, because I need to multiply to be a negative number, I need one to be positive and one to be negative. So 1 and 15, there's no way I can ever get back down to 2 if I add those together. So it has to be 3 and 5, and I know I need one of these numbers to be negative. If I put the negative sign with the 5, then I'll end up with 3 plus -5, but that will never give me +2. So that tells me that the negative sign needs to go with the smaller number so that I add them together to get a positive number. So -3 times 5 does equal -15, and -3 plus 5 does equal +2. The last step I have to do is make sure I write these as factors. So I'll have x minus 3, I'll have x minus 3 as one of my factors times x plus 5 as my second factor. It actually doesn't matter the order in which you write these. So you could have written all of your answer here in example 3 instead as being x plus 5 times x minus 3. So either of these are correct answers because multiplication is commutative, so the order in which we write the factors does not actually matter. Same thing with example 1 and example 2. I could have flip-flopped the order that I wrote them in. And that will hold true for all the rest of these problems. I'm just going to write one answer for each one of these, though, as we keep going on. Okay, let's look at example 4. Example 4 says x squared minus 2x minus 35. Why don't you guys pause the video and factor example 4 on your own first. Okay, let's check example 4. So I'm looking for two numbers that multiply to be -35, so make sure you take that negative sign, and add to be -2 as well. Over here, I'm going to list some factors of 35. So we have 1 and 35. There's no way that those will ever add up to be -2. I could also do 5 and 7, and those must work because those are my only two factors on 35 then. So let's try 5 and 7. So one of these needs to be negative so that they multiply to be a negative number. And I want to make the 7 negative because 7 was the bigger of the two numbers and it needs to add to be a negative number as well. So if we check this, 5 times -7 does give me -35, and 5 plus -7 gives me -2. So those two will work as my factors. Now, of course, this is not going to be my final answer. This is just work to help me organize my thought process. So my final answer here will be x plus 5 times x minus 7. Or if you want to flip-flop those and write x minus 7 times x plus 5, that would work as well. Let's look at example 5 here. So example 5 and example 2 actually look really similar. There's one subtle difference. In example 2, we had a -11 versus in example 5, we have a +1. Do you guys think that that's going to make a difference, or will we just get the same answer here on problem 5 that we did in problem 2? So that positive sign is actually going to make a huge difference here. And the reason being is when we go to write and figure out our numbers, those signs in front of them really do matter. So I'm still multiplying to be a positive, but I'm also adding to be a positive number. So 3 and 8 are still going to work here, but they're both going to need to stay positive since they need to add up to be positive 11, which tells me then that my factored form is going to be x plus 3 times x plus 8. And although it looks really similar to the answer we got on example 2, the fact that this is a negative and this is a positive, and I have a negative 8 and a positive 8 makes a huge difference, and those are indeed two different answers. So make sure you're paying attention to the signs as we go through these. Why don't you guys pause the video and factor example 6 on your own first. Okay, let's check example 6. It says x squared minus 6x plus 8. So if I write my x games, it needs to multiply to be positive 8, because that's my c term, and it needs to add to be negative 6, since that's our b term. So if I think about factors of 8, I get 1 and 8, 2 and 4 would work, and those are actually all of my factors there. So let's think about these. Both of them multiply to be 8, but only one of those is going to be add to be negative 6. What two numbers will work here? So the two numbers that will work here is actually negative 2 and negative 4. Because I'm multiplying to be a positive, I need the same sign then, but because I'm adding to be a negative, they both need to be negative. Negative 2 plus negative 4 does equal negative 6. So my final answer in factored form will be x minus 2 times x minus 4. And there is our final answer. Okay, let's look at some more. So example 7 says x squared plus 9x minus 36. Why don't you guys pause the video and factor example 7 on your own first. So I'm going to organize our work here. I know this needs to multiply to be negative 36, and this needs to add up to be positive 9. I could list all the factors for 36 over here. So 1 and 36, I would have 2 and 18, 3 and 12, 4 and 8. Oops, that was an 8. 4 and 8. Hold on. And then my last set of factors is going to be 6 times 6. So one of these pairs have to work. They have to multiply to be a negative, which means one of them needs to be negative and one of them needs to be positive. But I need to add to be a positive number, so the smaller number has to be negative, and in this case, negative 3 and positive 12 will work, because 3 times 12 does give me 36, but negative 3 plus 12 gives me a positive 9. So as you're looking at each one of these, there's actually only one unique pair of numbers that will work when I factor a quadratic polynomial here. So for each one of these, all the numbers that I've been coming up with, that would be the only pair of numbers that would work for each one of these. So these are all giving me unique factors. I can write my final answer in factored form, be x minus 3 times x plus 12. Okay, let's look at example 8. So I'm going to scroll down so we can see most of the second page. Why don't you guys pause the video and factor example 8 on your own first. Okay, let's check example 8. So I know this needs to multiply to be negative 21 and add up to be negative 4. When I think about factors of 21, I have 1 and 21, and then I have 3 and 7. There's no way 1 and 21 are ever going to add up to be negative 4, so it's got to be 3 and 7. But because we're multiplying to be a negative, one of these needs to be negative, and the 7 is actually going to get the negative sign this time so that they add up to be a negative number as well. So my factored form then will be x plus 3 times x minus 7. There we go. Okay, why don't you guys pause the video and do example 9 on your own first. So example 9, we've got quite a large number here. It's got to multiply to be negative 72 and add up to be negative 1. Well, one thing I noticed, yes, 72 is a large number, but I'm actually paying more attention to the negative 1 here. The fact that -1 is such a small number tells me that my two numbers that I'm going to have to come up with have to be within 1 unit of each other. There have to only be a difference of 1 there, otherwise there'd be no way that I could end up with a -1. So when I start listing factors of 72, yeah, 1 and 72 is a factor, but there's no way that I can add those up to be 1. I want to think about factors that are closer together. So yes, I have 2 and 36, that's not going to work. 3 and 24, also not going to work. 4 and 18, well, they're getting closer, but still not close enough. We have 6 and 12, those got even closer, but the two that are going to work have to be 1 unit apart, so that's going to actually be 8 and 9. So although 72 is a really large number, when your B term or your middle term here is a smaller number, you're looking for two numbers that are closer together then. So I knew right off the bat that this first set of these was definitely not going to work because those numbers are not close enough together. But 8 and 9 will work. Because I'm multiplying to be a negative, I do need one of them to be negative, and the 9 this time is going to be the negative since that will add up to still be a -1. So my factored form here will be x plus 8 times x minus 9. Okay, I'm going to scroll down a little bit more so we can see both 10 and 11. And I want you guys to pause the video and try both example 10 and 11 right now on your own first. Okay, let's check example 10. So I need two numbers that multiply to be -6 and add to be -1. So again, I'm looking for two numbers that are close together. So 1 and 6 won't work, but 3 and 2 should work, or 2 and 3. In this case, I need one of them to be negative, and because I'm going to add up to be a negative number, it has to go to the bigger of the two. So that will be -3. So we'll get x minus 3 times x plus 2. Okay, let's check example 11 too. So this needs to multiply to be 36 and add up to be -12. Well, if I list some factors of 36, I'll notice that what I'm adding to is quite a large number, so the numbers probably don't have to be, well, too close together, but let's see. So we have 1 and 36, that's not going to work. 2 and 18, well, it could kind of work, it's getting closer. 3 and 12, well, now if I add those together, if I make the 12 negative, I'm going to end up with a -9, so that won't work. Well, let's list these all out and see. 4 and 8, that's not going to get me there. But then I also have 6 times 6. This one's going to work here. So this is a unique type of example we're seeing here, where the two factors here are actually going to be identical. So 6 times 6 does give me 36. I need to make them both negative, because -6 times -6 also is 36. But more importantly, -6 plus a -6 will give us a -12. So in example 11, we're seeing this first case where my two factors are actually identical. So we could write our answer as x minus 6 times x minus 6, but that's the same thing as writing it as x minus 6 squared. So either of these answers will work as your final answer. Okay, let's look at example 12. Why don't you guys pause the video and try example 12 on your own first. So in example 12, we're multiplying to be 9, adding up to be 6. Well, factors of 9 are 1 and 9. That's not going to work. Then I have 3 and 3. Well, that has to work. Let's see. If I make them both positive, they'll multiply to be +9, and they'll also add to be +6. So again, we're seeing a case where I have my two factors that are actually identical. So we could write this as x plus 3 times x plus 3, or we could write this as x plus 3 squared. And either of those two answers will work. Why don't you guys pause the video and do example 13 as well. Let's check example 13. So we're multiplying to be +49, adding up to be -14. You might have noticing a trend here that we're going to have the same two factors again of -7 and -7. Because 7 times 7 will give us 49, and -7 plus -7 will give us -14. So I'll end up with x minus 7 times itself, which I could also write as just x minus 7 squared. Well, that was not a square. Let me fix that. X minus 7 squared. There we go. And either of those two would be correct. So in examples 11, 12, and 13, we're seeing that we're getting identical factors, and sometimes that happens. Okay, example 14 looks a little different now. We only have two terms. I have x squared minus 9, but in my general form, we said we were looking at things that said x squared plus bx plus c. So what of these terms is missing that I don't have? The term that is missing here is the x term, or the linear term. So what that tells me then is this is actually the same thing as x squared plus 0x minus 9. So in this case, my b is equal to 0 then. And sometimes that can happen. So in this case, what I would have is I'm multiplying still to be my c. So I'm multiplying to be negative 9, but I'm adding to be 0. Well, the only way that I can add two numbers and get 0 is if the numbers are opposites of each other. So I'm looking for two numbers where one is positive and one is negative, and they have the same absolute value. Conveniently, factors of 9 would be 3 and 3, so I can use 3 and negative 3. And this will work because 3 times negative 3 is negative 9, and 3 plus negative 3 will give me 0. So my factored form then would be x plus 3 times x minus 3. This was that case in our last video that was the difference of squares. Okay, we have two last examples. Why don't you guys pause the video and do example 15 on your own first, and then we'll check it together. In example 15, we have x squared minus 100. So again, we just have two terms, but remember that's the same thing as secretly having x squared plus 0x minus 100. So in this case, what we have is we're still multiplying to be negative 100, but we're adding to be 0. So again, my factors have to be the same number, but opposite signs. Hence the name difference of squares. So from here, what I'm getting then is going to be a 10 and a negative 10. Since 10 times 10, or 10 times negative 10 gives me negative 100, and 10 plus negative 10 gives me 0. So my final factored form will be x plus 10 times x minus 10. Now, unlike examples 11, 12, and 13, I can't rewrite these as one term squared because they're not identical. So that negative sign does play a huge difference, so I need to keep these in example 14 and 15 as two separate factors. Okay, last example. Let's look at example 16. We have x squared minus 16. Again, that's no problem, although we only have two terms. That middle term is just 0x. So when I'm thinking about my x games, it's got to multiply to be negative 16, add to be 0. 4 and negative 4 will do the job. So 4 times negative 4 gives me negative 16, and 4 plus negative 4 gives me 0. So my factored form then is going to be x plus 4 times x minus 4. That will be our final factored form. Now, although this is the last example that's printed, I do want to bring up one thing, because you might be wondering it. So in these last three examples, we saw where the b term is 0. You might be thinking, well, what happens if the c term is 0? So what happens if I just have, so I'll make this example 17, x squared minus, let's say, 5x. So in this case, technically there is a plus 0 there, but that plus 0 is not going to do anything for this problem. So I'm going to go ahead and actually just erase it. Well, we've looked at problems like this, we just didn't talk about them in this form. So way back when, and the first time we talked about factoring in this unit, we said the first thing you should always find is a greatest common factor. In all 16 of the examples we did, there were no greatest common factor that I could first factor out. But that's something that we always want to be careful of and we want to pay attention to. In this example 17 here, we do have a greatest common factor. What would the greatest common factor of x squared and negative 5x be? So our greatest common factor here would actually be an x. So because the c term equals 0, so this is the case where what happens when our c term equals 0. When that happens, that tells me that my greatest common factor has to involve some type of x. Now, there might be a number in front of it, so I'm just going to put a number sign. So I could have a number times x, but I will definitely have an x in there. In this case, my coefficients are a 1 and a -5. They have no factors in common except for 1, so I just end up with really 1x. So I can go ahead and factor out that GCF. Remember, to factor it out, we put the greatest common factor out in front, and then inside is what's left over when we divide each term by our greatest common factor. So when I go to divide these, I'll have x squared divided by x. Well, that will just give me x. So my first term now is a single x. And then 5x, or technically -5x, over x will end up giving me -5 then. So I'll get x minus 5 left over. And this is the factored form for something when our c term equals 0. And we talked about these types when we talked about factoring out our greatest common factor. Again, we can always check any of these by distributing everything out. So in example 17, I could distribute the x back in. X times x will give me an x squared. So that takes care of the first term. And then x times -5 will give me a -5x squared. So that takes care of the second term. And in these examples 1 through 16, we could FOIL all of this out, combine like terms, and we will get back to the polynomial that we started with. So in this video, I just want to go back up to this beginning portion again to really emphasize this. So in this video, we focused on the backwards direction here, going from standard form, factoring it, and rewriting the polynomial in factored form. So this was all in this video. In our last video, we talked about how to FOIL, meaning I multiply and distribute everything out to get it back into standard form. So FOILing and factoring are actually undoing each other. So FOILing multiplies everything out to get down to standard form. Factoring takes a polynomial in standard form and factors it into two linear binomials then. And that's what we focused on in this video.